Hi, I'm going to go over part C of the paper quiz for section 3.2. Okay, that's the one where you're given the graph of f and you're asked to graph the derivative f prime. All right, here we go. So here's the problem. Here's the graph of f, and we're asked to graph f prime. So the key is to understand that f prime is the slope of the tangent line of f. So what you do is you look at the tangents and then you graph the value of the tangent that you see. Okay, so let me give myself a xy axis here, or rather xy prime axis. All right, I want to show you the last piece first, this piece, the third piece first. This third piece, the whole thing have the same slope. Same slope throughout this third piece. Okay, it's a straight line, and a straight line has a constant slope. In fact, that constant slope is, if you look at the rise over run, then it has a rise of 2 and a run of 1. 2 over 1 equals 2. Okay, so for all of the part from here to here, the slope is equal to 2. So on the y prime axis, I'm going to draw the line from 2, a horizontal line with value of 2. So from x equals 2 to 3, y prime is equal to 2. Okay. So that's the key for drawing f prime. You look at the slope and then you graph it somewhere else. Okay, you don't look at the, you do look at the shape of the graph because that sort of gives you a hint. Okay, but the key things to look for is the slope. All right. Okay, now let's do it in order from left to right now. This piece, the first piece, the slope starts out at the beginning, the slope looks flat. The tangent line looks flat, so the slope is equal to 0. So I should say that the tangent is flat, so the slope is 0. So on my graph, I'm going to draw f prime or y prime equals 0. Okay. And what happens to the tangent line after that? It starts out flat, and then it increases. It goes up, right? And I'm not sure how or which way your camera is looking, but I want it to go up like this from left to right, because it starts out flat and it goes higher and higher and higher. Okay, and at the very end, it looks like it's about the same as that slanted line, a little bit, yeah, just about the same as the third segment. So it ends at about 2, maybe. Okay, maybe less than 2. So it goes from 0 at x equals 1 to something like 0 at x equals 0, and something like 2 at x equals 1. So just for simplicity, I'm just going to make it a straight line. Okay, you can draw a curved line, that's fine. Okay, so that's the first segment. Okay, now I have the first and the third segment. Now, how about the second segment? The second segment also looks like it starts out flat tangent. So the slope also starts out equals 0. So my y prime starts out at y prime equals 0. Note that the curve itself is way up at y equals 2, but I'm not looking at that y equals 2 value. I'm looking at the tangent line and what kind of slope the tangent line has. So for me, the slope is equal to 0. I'm going to draw it at 0. Okay, I'm not influenced by the fact that the graph of f itself is way up there at y equals 2. All right, so I start out with a flat slope, and what happens to it after that? It gets negative, and then more negative, and then more negative. So that means it's going to go down to some negative values, and I'm guessing that it's about almost the same as the other side, about equally steep as a straight line. So it's probably around -2 somewhere. So at x equals 2, the second segment gets down to about -2. So that's my second, that's my f prime for the second segment. Okay. Right. And finally, the last point is that there are all those holes I put in the open circle. I put in at x equals 1 and x equals 2. And that is because f prime is not defined at x equals 1 and x equals 2. A lot of you got that question correctly, that f prime, that f itself is not differentiable, that x equals 1 and x equals 2. That means there's no such thing as f prime at x equals 1 and 2. If there's no such thing as f prime at x equals 1 and 2, then the graph of f prime cannot have anything at x equals 1 and 2. So that's why I have all of these open circles here at all of these places. All right. Okay. Hope that helps.